Assalamualaikum and good day everyone. I'm Aisyah and I'll be presenting on my final year project called Sustainable Wastewater Management by PHYTOREMEDIATIon, a systematic review. In this presentation, I will be talking about the introduction, problem statement, objective and scope, methodology, result and discussion, and also the conclusion. About 70% of the Earth's surface is covered with water. 2.5% of them is the fresh water, and only 1% of the fresh water is accessible. Therefore, wastewater, surface water, and groundwater have become alternative sources to obtain more water for daily use. Due to the rapid industrialization and urbanization, wastewater has emerged as a significant source of emerging pollutants. Emerging pollutants have an adverse effect on the environment as well as human health. Therefore, it is important for the emerging pollutant to be removed completely from the wastewater to avoid any further impact on the aquatic environment. Emerging pollutants can be treated efficiently through biological wastewater treatment. In this study, I'll be focusing on 3 technologies which are activated sludge, membrane bioreactor, and phytoremediation. Activated sludge is a conventional wastewater treatment that is capable to degrade endocrine disruptor through isolation of bacteria. Membrane bioreactor is an advanced technology that is proven to be efficient in removing emerging pollutants that can be removed in activated sludge. Phytoremediation is a method which the emerging pollutants are absorbed in the plants through roots and shoots. So what is the main issue that encouraged this study? Previous research found that emerging pollutants have an impact on aquatic environment and human health. UV filter, an active ingredient in sunscreen, can cause coral bleaching and lead to coral death if continuously released in the wastewater. In order to remove emerging pollutants, wastewater treatment is used. Conventional wastewater treatment cannot remove emerging pollutants efficiently, thus more advanced technology is introduced. However, it is expensive and has high energy consumption. Alternatively, phytoremediation is proposed as the sustainable wastewater management that can remove emerging pollutants effectively. There are 3 main objectives of this study. The first one is to discuss phytoremediation as a recent sustainable wastewater management. The mechanism of phytoremediation and the sustainability are explained. Next, to determine the emerging pollutants that usually treated by phytoremediation. Pharmaceutical, personal care products, and heavy metals are the emerging pollutants that are reviewed in this study. Lastly, to compare phytoremediation method with other wastewater management methods. The comparison between phytoremediation, activated sludge, and membrane bioreactors are based on the effectiveness in removing emerging pollutants, the pros and cons, as well as the cost of the technology. In this study, there are 3 main steps to find the information: identification, screening, and eligibility. In identification step, 3 databases were used to find the information regarding the topic, such as Wiley, Sage, and Science Direct. The keywords were used including wastewater treatment, emerging pollutants, and phytoremediation to make it easier to find related published articles. From the keyword searching, 304 published articles were discovered. During screening process, the articles that were published before 2010 were excluded, thus leaving me with 177 articles. Articles which did not fulfill the inclusion criteria were removed during the eligibility process. Type of emerging pollutants, type of biological wastewater treatment, and the impact of emerging pollutants in wastewater are the characteristics included in this study. With my inclusion and exclusion criteria, 12 articles were selected. The information that have been extracted from 12 articles are tabulated according to 3 biological wastewater treatments: the activated sludge, membrane bioreactor, and phytoremediation. The data were compared based on several criteria, including the removal rate for each type of emerging pollutants, the cost of the technologies, the advantage and disadvantage of the wastewater treatment. From the table, we can observe that each technology can remove effectively different types of pharmaceutical waste. The highest removal rate of sulfamethoxazole is 76% by membrane bioreactor. Phytoremediation is the best technology to remove ibuprofen and diclofenac compared to the others. For the personal care product, 96% of them have been removed effectively by phytoremediation, following by membrane bioreactor with 95% and activated sludge with only 40%. The removal rate of 4 heavy metals are compared in this table. The heavy metals included are copper, lead, nickel, and zinc. Phytoremediation has the highest removal rate of heavy metals compared to the other 2 technologies, ranging from 84 to 99%. Only partial heavy metals were removed by the activated sludge. This shows that activated sludge is not a good technology to remove heavy metals from wastewater. The comparison of the cost that is stated in this table were obtained from China market price. Phytoremediation is the cheapest technologies compared to the others, as it is only cost for $37.7 per meter cube. Membrane bioreactor, on the other hand, is the most expensive with $540 per meter cube. The activated sludge and membrane bioreactor have the same advantage, where it only requires small space to operate. For phytoremediation, less energy is consumed during the absorption process. Activated sludge should not be considered as treatment for emerging pollutants, as it can lead to greenhouse gas emission, which are dangerous to our environment. Carbon dioxide is one of the gas that is produced from the activated sludge. Higher energy consumption is the downside of the membrane bioreactor because it will increase the operational cost. The dependency on season, pH of water, and the amount of rainfall affects the performance of phytoremediation. From this table, we can see that phytoremediation is the best technology to remove emerging pollutants from the wastewater. Having achieved the objective of the study, here are a few things to summarize the systematic review. Phytoremediation is a sustainable wastewater management as it is environmental friendly, low energy consumption, and low operational cost. Next, pharmaceutical, personal care products, and heavy metals are the emerging pollutants that can be treated effectively by phytoremediation. Lastly, phytoremediation has the highest removal rate of emerging pollutants compared to the other wastewater management. For the recommendation, more research on phytoremediation is needed to maximize the effectiveness in removing emerging pollutants and to ensure that this technology can be used in any condition. Thank you.